Tutorial I'm going to go over 93, assignment 93 is static electricity for sphere, right? Sphere A and sphere B, and this is before and this is after, right? Okay, the same sphere A and B, right? And now after, what do? You just connect them by an object, right? I want you to find out what type of object this one, given one information, and that is this is charged and this is uncharged, and this is charged and this is also charged. Okay, so now let's go to the scenario 2. Scenario 2, I also have 4 spheres: sphere 1, sphere 2, sphere 3, sphere 4. This is A, this is B. Sphere A and B, this is before and this is after. After, what happened, you are putting them together, right, by an object, let's say a purple object. This is A, this is B, this is also A, this is also B. What do you know? This is charged, this is uncharged, this is charged, this is uncharged. Okay, so now it is obvious that this object is a conductor. How do you know this is conductor? Well, this conductor is something that allows electron flow freely, right? So electron can flow freely. So from here to here, as soon as you are making connection between these two spheres, electron started moving from here to here, making this one charged as well. In this case, this is okay. So example of this one should be, I don't know, copper. So you take an electric wire, this wire, the insulator is outside, or you take this wire, all right? So insulator is outside and you cut it, and there would be a copper wire, and that carries electrons, and that is charged, negatively charged, right? So this is wood, right? This is insulator. So insulator, right? This is insulator. What does that mean? That means electrons cannot move freely. Electrons can move freely. Why electrons cannot move freely is because just like this one, electrons can flow freely in the conductor. Electrons cannot move freely in the insulator, right? So an example of this could be wood or plastic or things like that. If someone electrocuted and you don't want to throw water, because water is also conductor, you don't want to pull him or her, is because you yourself is also a conductor. You either use the wood or plastic or things like that. You use the insulator to save someone who is electrocuted. Okay. Now, what did you learn? You discovered that the charge, right? You discovered that the charge can transfer from, charge is electron, right? Electron can transfer from one object to the other object if there is a path, and path made of conductor, right? So what can we do with the charge? That's what we're going to discover now. Let's make a connection between mass and charge. So mass. So let's consider first mass. Okay. So mass. This is mass, right? So let's consider mass. Mass as a unit is kilogram, and charge as a unit is coulomb. The mass is Newton universal law of gravity, while Newton's second law, mg, which is also Newton universal law of gravity, big M small m over r squared. And this is the Coulomb's law, K big Q small q over r squared, or and the F is equal to QE, right? Okay. All right, so this one is similar to this one, and this one is similar to this one. Okay, so now what this one can do, that's what we're going to show. We're going to show what this one can do. As you see the big mass, right? The big mass can create what do you call the G field. All right, now let's see what we are talking about when we're talking about G field, right? When this marker falls to the earth, right? Earth is a sphere, right? But from the point of this marker, right, it is falling to the flat surface, although earth is a sphere. All right, this marker, if it has eyes, then it would experience it. It would see that it is falling to a sphere, right? It is falling to a flat surface. So this is earth, right? The earth. When we talk about earth, we are talking about the big mass. Big mass. Let's draw it again. So earth and big mass. Big mass create and the G field. So these are the G field, right? All right, G field. Now, when we talk about G field, who created this G field? This big mass created the G field, right? Now we want to find the strength of this G field. To find the strength of the G field, we want to draw an apple, let's say 1 kilogram apple, to find the strength of this G field. Now, what is the equation of the G field? Well, the equation of the G field is F G over M, or we can also say that we can use this formula mg. We see that is equal to, we see this, right? We see this G big M is small m over r square, right? So m cancel, so G is big G m over r square, right? So we're going to write that now, big G m over r square. By the way, this is big M. This is big M. Okay, good. This is the G field. Now we want to find the strength of the G field using this equation. So what would be the strength of the G field? G is 6.67 times 10 raised to negative 11, M is 6 times 10 raised to 24, and R is 6.37 times 10 raised to 6 square. So the G is 10 meter per second square. So this G field is 10 meter per second square. So the apple is accelerating with 10 meter per second square, and this is the attractive force. The gravity is always attractive force. Now we're going to use this understanding to understand the E field, electric field, a concept discovered by Faraday, Michael Faraday. Okay, this concept was by Newton, and this concept was by Faraday. Okay, now to understand the G field, what do we know? G field is, of course, you have F over M. In this case, is going to be force over Q, right? In this case, this is big G, so this has to be big K, and this is big M, and this has to be big Q, and this is R squared, right? Okay, now we are talking about, this is always attractive, right? But this one can be attractive and repulsive because we are talking about two types of charges, right? Positive and negative. So positive and negative, they are attractive. Negative, repulsive, because like charge, and positive, also repulsive. Now let's consider only positive charge. The charge goes to outward direction, and negative charge goes to inward direction, right? Okay, good. Now let's consider a big Q, and the electric field created by the big Q. When electric field created by E field created by big Q, what happened? The big Q is negative. Big Q is negatively charged. So negatively charged big Q, and if you want to put a small q, and a small q by definition always positive, then of course this one would be inward direction, right? So all direction, if you have the all direction, but this one will only perceive, this one will only, if this one has I, from point of view of this one, the electric field lines is toward a flat surface, right? Okay, like just like this. Now this one would be accelerating downward. Why? Because this is negative, and this is positive. Positive and negative, they attract. Okay, good. Now let's say this is just 1 microcoulomb. I want you to find the acceleration. Okay, maybe this is bigger than, way bigger than this acceleration. This acceleration is just small, 10 meters per second. All right. Okay. Yeah, 10 meters per second is good. All right. Let's find this acceleration. To do that, let's do it over here. We're going to first find this microcoulomb. 1 microcoulomb is equal to 1 times 10 raised to negative 6 coulomb. And then we want to find 10 raised to negative 6 coulomb is how many electrons. So 10 raised to negative 6 coulomb times coulombs electrons. 1 electron is 1.6 times 10 raised to negative 19. All right, so you have 6 times 10 raised to 12 electrons. All right, in 1 coulomb. All right, so now you want to find how many kilograms here. So 6 times 10 raised to negative 12 electron times, you want electron cancel, and you want kilogram over here. 1 electron is 9 times 10 raised to negative 31. So you have about 5 times 10 raised to negative 18 kilogram. So now we are ready to find the acceleration. So F is equal to ma. So Fe, that means EQ is equal to ma. So acceleration is EQ over, of course, m. E is, let's say the electric field of this one is 10 Newton coulomb. So 10. Q, I gave you the Q. Q is 10 raised to negative 6. And I gave you the mass. What is the mass? Mass is 10 raised to negative 18. Okay, so we are talking about acceleration is 10 raised to 12 meters per second squared. So this is way bigger than 10. Why is that? Because the mass is almost 0. A small mass means big acceleration. Okay, good. Now we're going to try to understand electricity, making connection between the charges and electricity and light. So when we talk about electricity, what is electricity? Electricity is a form of electricity is a form of energy, right? That you can find them in the atom, right? Okay, form of energy inside an atom. There are 2 types of form of energy inside atom. There are 2 types of electricity. One is static, and one is dynamic. Static one is charge at rest. And the dynamic one, charge in motion. Static one today, the dynamic one has another name, current. Okay, we're going to talk about current tomorrow. Just today we're going to pay attention to the static one. A static one was discovered by Thales about 600 BC, long time ago, right? So he used ember. What is ember? Ember, another name of ember is actually electron. Ember is a Greek word, means electron, right? So ember is a tree resin that you can collect from tree. Over the years, tree accumulate this type of thing we call the tree resin to protect itself from enemies, right? So you take the tree resin, you rub it against a cloth, and then it becomes charged, and then if you bring it to the leaves, then it can have the leaves behave certain way. For example, if you take a balloon and rub it against your hair, what happens? all the electrons going to move to the balloon. What would be the reaction of your here? Your here would be positively charged and your here will stand up, right? Because if this here is positively charged, this here is positively charged, this one will repel this one, right? And they want to move away from each other because of repulsive forces between the heres, right? So the here would be ended up standing up, right? And what happened to the balloons? Balloon is negatively charged. If you bring the balloon to the wall, it can polarize the charges on the wall, on the surface. There would be only positive charge because negative move away, because balloon has a negative charge, negative, positive, negative from the balloon, positive from the wall. They attract each other, right? So as a result, the balloon would be stick to the wall for not for a long time, not forever, but for a good amount of time. So what do we call it? We call it static electricity. What does that mean? It's the imbalance of charges on the surface of a body. In this case, a balloon surface has some imbalance charges, which is electron came from your here, and on the other hand, the wall has imbalance charges because all the proton are on the surface and electron moved away because electron from the balloon repel electron inside the wall. And this was first discovered by Thales 600 BC, but there is a long gap. After a long time later, 1752, someone discovered charges, right? And that is Ben Franklin. What did he do? We are talking about we're actually talking about 1752. So we're going to go to 1752. 1752, Ben Franklin. So Ben Franklin discovered charges. This is how he did. So if you consider cloud, so this is cloud, and this is another cloud. So on the cloud, there would be an imbalance of charges. So this is positively charged, this is negatively charged, positively charged, negatively charged. When there is a positive charge and negative charge, imbalance of charges, polarized, right? Cloud polarized. Then there would be a strike between cloud. What do you call this strike between cloud? You call it lightning. Okay. So now Benjamin Franklin wanted to discover that, hey, this lightning caused by charges, right? If that lightning caused by charges, then of course he would be able to create those light, harness the power of God to create light and light up the create electricity and light up the houses, right? And that's what he eventually tried to do. But before that, he had to discover that the charges, static electricity caused by the imbalance of charges. So he did use a kite, and this is a rope. This is a rope, all right. And then in here, he would be standing up with his son William, right, and holding on the other end of the rope. So this is a rope. Rope gets wet because it was rainy. So the rope become a conductor because the rain. Okay, and he put a key on the rope, and he put a storage to store the charges. Okay, so when the kite experiences the lightning, because of this is weight, the electrons started moving, and moving to the key stored the electron inside what we call now is capacitor. So he pulled the rope and he insulated the rope, because on the other hand, if he did not insulate the rope, because the rope was weight, he would have been electrocuted. He insulated it, he pulled it, and he touched the key unknowingly. But when you do something accidentally, then you discover something accidentally. So what happened is spark. When he touched the key, spark. Thus he discovered that charge, and he called positive charge and negative charge, right? Okay, and that's what we're going to be talking about. we're going to be talking about positive charge and negative charge and how we can polarize positive charge and negative charge and how we can transfer them. But to do that, we have to discover something. We have to discover a machine, because hey, tree destines are good, but not as useful as a machine. And we're going to name the machine is electroscope. Electroscope was discovered by Abraham Bennett 1800 in England, right? So this has a knob, so this is called knob, and this is called leaves. All right, so the electroscope is this is a conductor, right? Knob is a conductor. Electroscope is neutrally charged. Okay, to show that it is neutrally charged, we have to show that there are 5 positive charge and 5 negative charge. So this is neutrally charged. Now I want to bring it very close to the same electroscope. I want to bring it to a positively charged rod. So this rod is positively charged. So what happened to the electroscope? This is what happened. All the negative charge going to come as close to the rod, because the negative attract positive and vice versa. And on the other hand, this is going to be like this. And what about this one? This one we don't draw it, because we only draw the dominant charges. Okay, good. So there would be no charge lost, there would be no electron lost, there would be no electron transfer. However, there would be a redistribution of electrons and protons. We call it redistribution, or we call it polarize. Okay, good. Now, if you remove the rod, what happened? If you remove the rod, no rod, then you get back the same thing you started with, right? So this is positive, this is positive, this is positive, this is positive, this is positive. So 5 electrons, 5 protons. However, there is some mistake over here. There should be a repulsive force between these 2 leaves. Repulsive. If it is repulsive, then this must be repelling. So the left leg repel with the right leg is because this is positively charged and this is positively charged, right? Like charged repel. Okay, good. So what do we call it? We call it charge by induction. Charge by induction. Charge by induction means charge without touch. Without touch. Now you're going to see charge by conduction, charge with the touch. And how the charge with the touch would look like, let's take a look. Charge with the touch, so this is what you have before. So before you have same number of electrons and protons on the electroscope. Now scenario number 2, you have the same electroscope, however you being a positively charged rod, right? So then there would be a redistribution of thing. However, instead of doing that, what you want to do? You want to touch it. All right, this rod touch the electroscope. If you do touch it, what happened? This is positive. Now the electrons 1, 2, 3, 4, maybe 1 electron transfer, right? Okay. So now if you remove the rod, what happened? All right. If you remove the rod, this is what's going to happen, right? 1, 2, 3, 4. Okay, so this is completely permanently, this object become permanently charged. Here we have to fix it. This is repulsive, so make sure we have this one is positive, 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 positive. This one is also repulsive. Positive, 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 positive. All right. So this is we call charged by conduction, or charged by touch. Charged by touch, you can permanently make an object charged. So this is charged. This didn't go back to this scenario. Okay.